Okay, so we've been talking about oblique triangles. What does that mean? There you go, triangles that don't have a 90-degree angle. Perfect. So you're either going to have 3 acute or you're going to have 1 obtuse and 2 acute. And in order to solve these triangles, we've been looking at 2 laws, the law of cosines, which we haven't seen really since the day before yesterday, and the law of sines, which we've had a little more practice on. That's just creating a proportion. Now, in order to use law of sines, you do need what? You need a pair, so you need an angle measure and the side length directly across from it. Okay. Now, let's go ahead and review quickly the law of cosines. So let's say I have an oblique triangle, this one right here. Somebody go ahead and give me 3 letters I can use to name it. Okay, what's that, Raphael? Well, let's try something besides ABC because that's what's in our notes. I heard T, what? T-E-F? Okay. T-E-F. There we go. All right, so T-E-F. So this base would be side E, this would be side T, and this lowercase would be F right there. Okay, so let's say that given this triangle TEF, I wanted to go ahead and write the equation for law of sines starting with side E. Okay, so let's see if we can remember the pattern. So I'm starting with side E, but there's something I need to do to that side. We square it. Okay. So E squared would equal. Okay, so we take the other 2 sides, we take the sum of their squares. Now what? Minus 2 times F times T, 2 times their product, times the cosine of E. Whatever side you start the equation with, you have to finish with the angle opposite that. And then you can come up with one very similar for both F and T. Okay, good. Well, one of the things that we want to go ahead and look at briefly at the end of this section is what if we want to go ahead and find the area of one of these oblique triangles? Okay, and we don't want to, take the time to drop a perpendicular segment so that we can have a base and a height and go from there, because we all know 1/2 the base times the height is the area. But there are 2 other ways for these oblique triangles that I want to go ahead and introduce you to. One of which is called Heron's formula. Okay, so the area, it's all contained below this radical here, this expression, S times S minus A times S minus B times S minus C, where S is provided to me as half of A plus B plus C. So think back to geometry. I mean, what would A plus B plus C mean to the triangle? Starts with a P. That'd be its perimeter, right? So S is just half the perimeter. Well, it's a very simple, straightforward formula. We just go ahead and plug in all the information. And you want to use this if your oblique triangle is given to you as side, side, side. Okay, well, let's just try an example and see what you think. Find the area of ABC to the nearest 10th. Okay, so first let's start with S. That's 1/2 the perimeter. So I'm going to say 44 plus 53 plus 47. So I'm taking half of what? 144, which is going to give me 72. Okay, so half of the perimeter is going to be 72. Now I'm just going to take all the values I have and I'm just going to substitute it directly in. So the area is equal to, so I have this long radical. So we start with S, 72, times S minus A, so 72 minus side A is 47. Then we'll have S minus B, so 72 minus 53. And we'll finish up S minus C, 72 minus 44. There we go. And really, when it comes down to it, does the order that you put those sides in matter? No, not at all, because the multiplication is going to be commutative. You can switch those around. That doesn't make a difference. Okay, one other thing you could do, we can go ahead and simplify these differences before plugging it into the calculator, but ultimately I'm going to have to plug it into the calculator anyway. So just like we were doing with law of cosines, we just let the calculator take care of all of that. Does anybody want to simplify those, or do you just want me to type it in? Susie, you want me to simplify? Oh, you already got it? Okay. Well, let me catch up to you. So let me go ahead and type in this whole thing right here. So I've got one big radical starting with 72. And then I remember, let's see, we had a 44, 72 minus, there was a 47. And I want to say there was a 53, right? Okay. All right. So here is Huron's formula with everything plugged in. Susie, what should I be getting? Okay. 978.57. So let's say to the nearest tenth, we'll say 0.6. So 978.6, and I want to say we're dealing with feet. Yes. So 978.6 feet squared. There you go. There you go. And I think what I'm going to go ahead and do at some point, because I'm not going to take class time to do it, but I think it'd be nice if you saw it. I'm going to go ahead and derive where we got this formula from, and I'll go ahead and post it to the website so you can see that. Okay. Because even on this homework assignment, you are going to derive something for me. You're going to prove one of our rules. Okay. So any questions on Huron's formula? Pretty straightforward? Okay. Well, let's try this next one here. Same thing. We want to try and find the area of triangle GHJ. So let me give you 1 minute. Okay. Let's see if you guys can come up with that area to the nearest tenth. So again, we're talking square feet. All right. Now, you may not be done, and that's okay. But you'll notice I went ahead and started. I found the perimeter to be 72, so what is S? 36. So half that perimeter is going to be 36. Okay. And then now it's just a matter of substituting in. So we have the 36, and now we're going to multiply by the three differences. So 36 minus 19 times 36 minus 21 times 36 minus 32. Okay, and then let's just plug it in and see what we got here. So 36 times 36 minus 19. Let's see, we had a 21, and we also, what was it, 32? Okay. All right, so what should I be getting for the area as soon as I push enter? Okay, 191.6. That is exactly right. 191.6, again, we're dealing with feet. So square feet. Okay, there we go. And that is Huron's formula. If you have all three sides of the triangle, very fast and efficient way of finding the area. Okay, any questions?
What if we had to convert it to inches? Do we just do the dimensional analysis?
What if you did want to convert to square inches?
Yeah.
Yeah, you can go ahead and do that.
Do you just do the dimensional analysis at the end, or?
I'd probably go ahead and do it at the end. Yeah.
Okay. Sweet.
Because you could go ahead and determine the number of inches in 1 square foot, and then just go from there. Yeah.
Sweet.
Okay. All right. Good. 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 Well, there's one other way. If you don't have three sides of the triangle, what if you only have two sides and one angle? Okay, so this one doesn't have a specific name. It's just for a specific case if you have two sides and the angle. Now, the angle has to be the included angle between the two sides. So whatever two sides I'm provided, the angle has to be between those. It has to be created by those two sides. And in fact, you'll notice, just like the law of cosines, there are three different versions of it because it could originate from any of the three vertices of the triangle. But all you need to do is just take 1/2 the product of those two sides times the sine of that included angle. Okay? So this one, we have everything we need. Let's go ahead and try to find the area of ABC. Okay, so the area would be 1/2 times the product of the two sides. I've got a 52. I've got a 39. And then we're going to be taking the sine of 25.89 degrees. Personally, I like this formula because it has a lot of SAS. SAS. Yes, let's type it in the calculator. Okay. All right, so let's see. 0.5 is my 1/2 times, and that joke totally made me forget my numbers. 52 and 39 times, I want to say it's the sine of 25.89. Okay. All right. So this one is just as direct. Once you have all your values, you plug in. Looks like I'm getting 442.8. Is that what you folks are getting? Okay. 442.8 square inches. There we go. Okay, so Huron's formula and side angle side for oblique triangles. Any questions? Anybody having a hard time on these last ideas? All right, so in the last bit of time for class today, we are going to go ahead and start our district assessments, but I'm going to go ahead and give you your homework assignment. You have a little bit of time to go ahead and start on that today. Remember, when's it due? Monday. It's due on Monday. So let me go ahead and stop this recording.